Hello everyone, in today's class we will be talking about the graph of a logarithm function. So now when I open decimals.com, I'm going to show you some function about their graph, such as y equals to common log of x. Well, the black line shows the graph of a base of 10 logarithm function. What about y equals to ln, which is the natural log, so it shows the blue line. So now we already have the graph log base 10 of x, which is common log, you will not see the 10, and then natural log, which is ln x. Okay, so what if I want to see the base of 6 equals to x? So in this case, remember the change base property, so we can just put in log base 6 of x in decimal. In fact, we need to put in either use a common log or natural log to do the change base property. So if I want to see the graph of log base 6 of x, I'm going to put y equals to log x divided by log of 6. So you will see it on the green line. And now let's continue, such as I want to see log of x divided by the base, let's do 100. So as you can see, if you pay attention to this graph, they all have the same pattern, right? They all look like this one, and they passing one common point. If you zoom in, you will notice that they were passing 1, 0. And what will be their domain? So by observation or graphically, the function g of x equals to log base b of x in general. B can be any number. The graph has a x-intercept always, no matter what basis, for all b, which is 1, 0. And also the graph has a vertical asymptote. Which is the graphical asymptote is the y-axis, right? Which is when x equals to 0. And what else? And the graph is increasing and the concave down. It's increasing on its domain, and also the graph is concave down. And then for all the domain, what's the domain in general? The domain of the function is from 0, not including 0, to infinity, which means x greater than 0. And the range of the function g of x is going to be all the real number, right? From negative infinity to infinity. If your graph can be infinite many big, look at the graph in here, they can go as high as you can and go as down as you want to. So except for 1, 0, the graph also passing through another point. Think about that. When the base g of x equals to b, when x equals to b, I have the log base b of b. So this is equals to 1, right? This is always true. So that means the graph is always passing through 2 points. 1, 0, and b, 1, whatever b it is. Well, another thing that we need to take a look is the graph. Let's say just the basic graph, log y equals to log of x. And we know that logarithm function and the exponential function, they're inverse. So that means, let's look at the exponential function. Y equals to 10 to the x. Since the base is 10, so the logarithm function should be 10. So look, these two are inverse function. If they're inverse, they should be symmetric over this line, y equals to x, right? So now we can do another experiment, such as instead of log of x, we can use the natural log of x. So that means this is going to symmetric over the base e to the x. So look, they're symmetric. So that means logarithm function is going to be symmetric with its inverse function, which is the exponential function, is going to symmetric over y equals to x. So another thing is, how do we graph a logarithm function? So this is similar to the transformation. We can apply the transformation to the graph of logarithm function, such as if, imagine that, I'm going to delete that. If I'm giving you a natural log function and I want you to graph g of x equals to ln x plus 2, what does the function look like? If you add 2 to the whole function, the function will have a transformation vertically, either up or down. Since you add 2, so that means this is going to be up. So let's check this out at 2. So look, the green line is 2 units up from the black line. Well, what if I subtract a number from x, such as I subtract 3? So the function is going to be what? Shift to the right 3 units, like what we say. So if I'm just do it towards x, it's going to be shift to the right 3 units. What if I take a negative? Well, let's take a look. If I take a negative of the whole function, ln is going to be upside down, reflecting over the y-axis. Well, what if I take x just to take negative to the x? Then you will have a vertical reflection. And also compress and stretch. So if you times 1/2 to the whole function, remember this is timing the whole function, then you will have a compress, vertically compress one-half factor, right? But instead of, okay, let's compare these two. But what if I have ln times 1/2 2 to x? Then look at the purple line compared to the original black line, the black graph. What happened? Well, this gives you a horizontal transformation, right? Since you times something that less than 1, so this gives you a horizontal stretch. One-half, which is 2 units. You stretch horizontally 2 units. Okay, what about the combination? If I want you to sketch the function h of x -3 logarithm function x minus 2 plus 1, what does this function look like? Well, the first step is you need to know what is the basic function or the parent function. The parent function is going to be log to the x, right? Net common log to the x. And then you will going to subtract 2 from x so that you will have shift to the right 2 units. So now let's draw this. Common log to the x is going to give me the black line, and then the second transformation is going to be the log shift to the right 2 units. So you get the red one after shift to the right 2 unit, and then you times -3. Or you can do it two separately. You can do the negative first. So I will have a flipping from the red graph, right, vertically. So I have a negative log x minus 2, so that I have the blue one. Or you can do it together, and then you times 3, that gives you what? You flip it, and also you will have a vertically stretch. So look, the blue line is more stretchy than the red one. And then the last one is we will add 1, which means from the blue line, you're going to move the function up 1 unit. So this is, look at the green one. The green line is exactly the same function, but transform from the blue line to the green line, you just move the whole function up for 1 unit. So when you do these changes, you need to pay attention to the vertical asymptote. So vertical asymptote is not going to change by the vertical transformation. So what will be the vertical asymptote? Well, we only did one horizontal shifting, which is shift to the right 2 units. So that means your vertical asymptote is going to be x equals to 2 now, because shift to the 2. So the point that you're passing is no longer 1, 0. At beginning, you're passing 1, 0, and then you shift it, so you will get what? Well, first you shift to the left, shift to the right 2 units, so that means your passing point is going to be 3, 0, and then you stretch negative 3 to, and then flip it upside down. So that shouldn't change that point at all. But, and then at last you shift up, so that means the point is going to change to 3, 1. So now let's look at our green line. They are shifting to 3, 1. If we look at 3 of the point, we will have 3, 1 in here. But they didn't point it to you. They just show it the intersection point. All right. So again, but we talked about that earlier. It's not just shifting to that point. We also have a point that we're passing through, which is the base and then 1. So that means the function, the base is going to be 10 and 1. So after you shift to the left, so, you minus 2, that means you shift to the right. So your point is going to be the horizontal coordinate is going to add 2. So you have a 12, 2. And then what about you times negative 3? Here should be 1. So when you times negative 3, that will stretch the point. So in this case, when you stretch vertically, that means your 1 is going to change, right? So that means you're going to pass 12 and then negative 3. And after that, you need to shift up. So that means you're going to pass the point 12 and then negative 2, because you plus 1 on the y coordinate. So that will be the point changes. So when you're doing the graph of a logarithm function, you need to pay attention that the 2 important points that they're going to pass in, 1, 0, and the base, then 1. Also the asymptote, the vertical asymptote. Okay, so that's it for today's lessons. Let me know if you have other questions. Make sure that you will play around decimal to get more visualize of the logarithm function graph. See you next time.